Howdy. This is a video that I've been looking forward to making for a long time now. Because, like with the recursive functions video, this is one of my favorite topics, but it's also one of the hardest topics to learn things about. The data for it is very sparse. The topic for today is going to be lists and data storage, and why you should bother with data storage and how to work around it. So, first, let me introduce how you would, what is a list? How would you even make a list in Minecraft? Well, step one... Oh. Caught me off guard. First thing that you should do, if you ever want to do this, is do data modify storage. And I have something that I made previously. Tutorial test, and I think it is input? Oh wait, it would be get. Hold on, give me a tick. It's list, okay. I created a list of a series of values. And each of these values are stored as their own entry in that list, and I can access them at any time. So suppose I want to do get input 0. I want to get the very first value in that array. So do bear in mind, I'm going to be using array and list interchangeably, because in this context they're almost the same, but depending on your programming language, they mean very different things. But I'm going to accidentally use them interchangeably. I'm almost certain. But the thing with these lists is that think of, suppose that 0 is the first value, 4 is the second value, 5 is the third, so on and so forth. Subtract 1 from all those values, and that's what the index is. So 0 is actually the 0th value, index of 0. 4 is index of 1, you get the deal. So if I check... Oh, it's input still. What am I doing? List. It is the following contents of 0. Right? If I go up to 1, it becomes 4, 5, 8. You get the picture. Not only that, but I can also modify it at will. So suppose that I want to modify... Let's say modify the first value and set it to 5. I do wish it showed this instead of just giving the ambiguous modified. But it worked. That now says 5. Suppose now that I want to make the first value into a string. I can do that. Or perhaps not. If you notice, it's not working correctly. This is still operating under the same preconditions this is operating under some basic preconditions. The list has a specific size, and values cannot be interchanged like that. In order for me to fiddle with turn something from a number into a string, I think even if I try to append it, it won't work properly. Append, yes. Because look. Oops. Pardon me. It doesn't work, because this is a list of numbers. Now, suppose that instead, let's do modify storage. Oops. Set value seven 0 to 10. Now if I check it, it's what you expect. And now, if I try and add this is not a number, it's added properly. If I get it, this is not a number is now applied. And the reverse is true. If I try to add a value of 100, nothing happens, because again, I cannot interchange the values. But that's usually not important. So quickly, I want to go over what these operations are before I get into the more nitty-gritty stuff. Append adds something to the end. Insert, it puts something in at a certain position without replacement. So suppose I wanted to replace 0, or suppose I wanted to insert at position 2. It would then be 1, then 7, then whatever the new value is, then 0, 2, 10. But if I were to do set, it would replace. And prepend, I don't think I've ever even used prepend, but it's like append puts something at the very end of a list, prepend puts something at the very beginning of a list. I've never found a reason to use prepend, but I guess it would be useful in some situations. Either way, there is another very important problem that I need to discuss with these. If you notice, up until now, I've only been using finite values for these indexes. You can only use finite values for these indexes is the problem. Like, suppose that I wanted to do, I don't know, I wanted to be based on a scoreboard. It'd be tutorial, test, cur. That doesn't work, because that's illogical. Even if I were to write it, were to do like this. I don't know how you do this. Is this actually a thing? Wait. Yeah, it doesn't look like that's a thing. There might actually be a way to do this with scoreboards. I'll have to check. I'll have to look into that. For the time being, though, let's operate under the assumption that I can't do that. But I'll have to look into that, because that can actually be incredibly useful. But under the assumption that you can't, you would have to do something a little bit different. And there are methods. Now, let me just get a couple of different colorful blocks. And these will indicate... Oh, lovely. I forgot I could even rain on super flat worlds. It's been a while. Put down the copper, netherite. Yeah. So, just imagine that all of these are one entry. My goal is to get any one of these values from one iterative function. So suppose I put in 3 to that function, it should output copper. If I put in 2, it should output this, it should output gold. And if I put in 0, it should output iron. Now, how exactly would you do that? Well, think about this. If you think about the number of steps away from iron, from here, diamond is 1 step away, gold is 2 steps away, copper is 3 steps away, etc. And that sounds obvious, but there is an application that we can use. There is a function that we can use that we can apply to this in order to make that happen. And it's a function that I have pre-written, but it's not a difficult function by any means. Oh god. Function called shift left. Now what I'm going to do is where I do that. Let's do data modify storage tutorial test input set from list. This is just setting input to be equal to list. It's going to be useful because what this function does is it sets the first value equal to temp. It removes the first value, and then it adds the first value back, but to the end. So let's think about this mechanically. Suppose that I apply this operation to this list right here. I'll keep this value in mind for later, remove it, and then plop it over at the end. Now, we've applied that function once. This is now at index 0. Now suppose we want to run it again. Store its value, remove it, put it at the end. We want to run it again. Store the value, remove its value, remove it, and replace it. This is what's known as shift left, and it's usually not done in this manner, because usually this is used in list operations when you want to remove a value. Because the way that a lot of lists are created with things like Java and Python is that you have an array of a fixed size that you cannot change. But you have some values that are defined within them, and everything else in that list is null. So when you shift everything over, the value at the end becomes null, and everything else gets shifted down. So you usually use it to remove values. In this case, though, we can use it in a different way and treat it almost like a Rolodex and just shift everything over, allowing us access to the values that we need. So let's apply this to our mechanisms here. Let's head over. We have that technology now. Now suppose that I do data get storage tutorial test input. The input is currently 170210. This is not a number. Now suppose I apply the function shift left. Then I get it again. It's been shifted down. Then I run it, let's say twice more to get 2 to the top. If I were to get input 0, after this, it would be 2. Suppose I want to get index of 1. 1, 2, 3, index 1. Or value of 1, I should say. So the solution here is to make a function that gets a value. We need to, let's see. Oops. We need to have it continue running until it gets to the value, and then output it. Now that's one thing, but another thing that we could do with it is get the size. Because something else to note is that you cannot get the size of an array like this. It's not like I can do input.length. This is not a good day for rain. Go away. I swear there's a game rule for that. Do weather cycle or something? Yeah. Turn it off. So another command that I have implemented, let me tab over real quick, is called getSize. This is a recursive function. Shift left you can call in a recursive function and it'll keep running until you say that it doesn't have to run anymore. But with get size, it has 3 commands. The first one will remove the first value of the sample array. If it works, it'll set this value to be true. If it's true, you add 1 to the size variable, and you run the function again. And it will keep doing this over and over and over again until the array has been emptied, and this returns false, because it tries to remove a value, and it can't. So then, as before, let's apply it to our function. Let's go modify input set from storage this. Oh. You serious? They already have the exact same values. It's awesome. That'll be helpful. And then let's do function. Oh, wait. First, because there's not really a good indicator of it in the function itself, so we can just do set. Set so it displays at the sidebar. And we're going to have to set its value to 0 because I was effing around with it earlier to make sure that it actually worked. Make sure that works. Okay. Slash function. I'm having a moment, sorry. 6. And that checks out. Because, as we saw earlier, there were 6 values in here. Now, it's not amazingly efficient. It did run 27 commands to do that, but unlike the previous one, where there might actually be a way to get an integer, there's no way, to my knowledge, to get the length. Now comes the part of the video that I'm kind of dreading. Suppose that you want to sort these numbers. Let me reload so that it gets set back to, let's see. It gets set back to the numbers. Suppose that you want to loop through, and I'm not going to implement this because this is a absolute beast to implement, but it's worth mentioning because it is just like an important mechanism. Suppose you want to sort it. You want it to be smallest to biggest. How would you do that? It's a very difficult question. And people have been mulling over how to do this stuff efficiently, basically since the inception of computing. The simplest way that you could possibly do it is what's known as a bubble sort. I assume it's named as such because suppose you have a line of orbs with numbers inside them, and you kind of like do this operation over and over again until you get what you want. So let's represent it by a series of cells. I'm going to do 0, 1, 4, 9, 3, 1, 2, 3, 3, 8, 0, -1. So what a bubble sort does is it runs through the same set of values over and over again. Every time it finds a value, it'll run a check. If this value is larger than this value, then they'll swap positions. And it'll keep doing this until it hits the end, and then if it has swapped anything in the list, it will run it a second time, and then a third time, and a fourth time, over and over until the puzzle is complete. So in this case, 0 is not greater than 1, so they don't swap. 1 is not greater than 4, so they don't swap. 4 is not greater than 9. 9 is greater than 3, so these two will swap. 9 is greater than 1, so they will swap. 9 is greater than 2. this will probably get pushed all the way to the end. So that worked, so let's try it again. 0, oops, what am I doing? I should be copying this. These two values swap. And then, like before, keep swapping values until you find a value that's greater than it. Now, as you can probably guess, this is not the most efficient program in the world. But it works. It's also probably the easiest one to implement with code. But again, I'm not going to. I tried my darndest, but it is extremely challenging. I might make a follow-up video where I do show off the implemented sort, but that'll have to wait because it is extremely challenging. Sorts are difficult, and they are also very difficult to make efficient. Because imagine this, but instead of with, what would this be? 12 values? Instead of 12 values, imagine this with 200 or 2000. How much slower would this run? Quite slow. If I recall correctly, this thing operates somewhere between... It runs somewhere between n and n squared lines of code. So it's somewhere between... It'd be somewhere between 12 and 144 loops of code, normally. That'd be what? 144 by... probably by 8 or something like that. This is very much napkin math, so I have no clue if this is the actual value. But it'd be, I think if I did my napkin math right, it would be something in the margins of somewhere between 72 and that much. And it would run 72 if it goes all the way through without finding any errors. If you run this on a sorted list, it'll just run through once, realize nothing's wrong, and then output. Excuse me. I'm going to take a drink of water. But with all of this said, there's still a nagging question. Why exactly would you use a list? What benefits are there? Well, a lot of it is a matter of personal preference. But personally, I like lists really just because they reduce the amount of redundant code. Yes, the operations are confusing and they can often be less efficient. But the hope is that as it runs, you have to run less lines of code to get to the same conclusion. Or more importantly, you have to run less lines of code. That's just me mindlessly typing out 200 different sets of code that cannot be used for anything above or below 200 or anything with weird values. In short, it's kind of like what's the word for it? It's future-proofing it, basically. It's more difficult now, but it'll be easier later. Now, what I'm going to do is show off an example of this that I think is quite cool. So kind of in the background, I've been working on a Skyblock Datapack, and I might show it off at some point. I think I enjoyed working on it, but it's nowhere near done. but let's spawn in a few zombies and see if we get a bite. What I implemented, yeah, it worked. And I implemented loot crates. There's a chance when you kill a zombie, and it'll make it work with most mobs in the future, but for now it's just zombies. When you kill it, it will drop you a set, or something from a set of unique loot. Now the question then becomes, how? How exactly did I do this, and did I do this with a wide assortment of if statements and horrible things like that? And the answer is actually no. There's a way that I did this that does not involve a bunch of if statements, but give me a moment to really add in this as a sort of bookend, so I can separate the tutorial stuff from what I'm about to pull up. Okay, save, skyblock. Sorry about that. So, this is a lot. This is a lot to take in. Let me try and break it down. If you notice, there's some common threads with these tables. There's the common, the rare, the epic, the legendary, and the unheard. And they're loot tables of different, or that have different sets of inputs. So for the common, you have all the saplings, wheat seeds, dripstone, ingots, just like generic good stuff. Rares is stuff like netherwort, soul sand, more specialized things. Epic tables, there's spawners, there's spawn eggs, a bunch of diamonds, a bunch of iron, netherite, a bunch of building blocks of certain types. Legendary is stuff like, I haven't implemented yet, but this is, when it spawns, it'll immediately transform into a chest's worth of End City loot. And there's also some custom items in there. And the unheard, all of these are specialized items. This is why I have this set up. This can be expanded to absolutely anything with an item ID. And if I wanted to add more values or remove values, I could just remove values. And it would not horribly destroy this data pack. So suppose that I wanted to spawn in some loot. I'll do function. What should I go with? I say let's go with unheard loot, because this is a lot of the cool loot. Oh, that was loud. I apologize. Usually it doesn't spawn right up. Usually it doesn't play the sound right on top of you, because it would normally come from a zombie, but whatever. It's an aspect of the void, and these are all going to have unique effects. But suppose that I wanted some epic loot. Pressing it over and over, and I get a whole bunch of interesting loot. And if I wanted to change any of these, I would just have to remove their entry from this initializer. So there's a whole bunch of stuff here. Let me clear out my inventory. Let's go with the unheard loot one more time. And again, that's really loud. I apologize. Why is it playing right on top of me? I guess it's because it's the dragon death sound. I bet it has a larger radius than usual. It's one of the aspects of void. Very dangerous and very powerful weapons and armor. And the last thing that I want to show regarding these tables is how they actually work, because I have their values here. But the question is, what do I do with them? Well, let me open up spawn common loot. And I should probably refactor it to be the array size. But for the time being, I'm fine with it. I can just, change a value and then head over here and add one or remove one if I need to. What it'll do is first it will iterate RNG. It will set a constant to be equal to 19. Then it will take the RNG value that I have generated and take the modulus mod 19 so that it ends up with a value between 0 and 18. Then I have a special version of shift left implemented, and this isn't the one, this is the one that I made earlier, that will keep running iter mod number of times. So RNG becomes this value, and then iter mod will make shift left run that many times. Now comes the part I neglected to mention earlier. It spawns an item, a barrier with a special tag. Then I have this commented out, it will run text that says replace data with, and then whatever the storage is. It'll play some particles, play some sounds, merge its NBT with the NBT from input 0. Because it's shifted left, I'm basically selecting a value out of that list. And then it removes replace. Because I think if I merge and I didn't have this, it would continue cycling through endlessly, and that would not be pretty. So now, let me go ahead and remove this comment from the tellrail. If I reload and run the common loot function again. There it is. Replacing data with item count 1 ID Minecraft apple. Like so. Every single time it runs, it will get one of the items from the loot table. Now, there's a case to be made for me to just use a regular loot table. Personally, I hate working with loot tables, so I avoid them at all costs. But I mean, there are applications to why you would want to use loot tables. So I guess that stuff is relatively well documented because people are good at working with .json files. So there's links available. I'll leave a link to the Minecraft wiki. But that being said, this is probably not the way that you expected the video to end, me floating in space in a skyblock map, but regardless, that's about all I got. Next video, I was originally planning on making it, sorry if it's a bit louder, I moved my mic over. Next video is probably going to be about a sorting algorithm. Yeah, I'm going to commit to that. Because it was originally going to be about loot tables, but the more that I think about it, the more I realize it's not really that interesting. It wouldn't be much other than me just blankly staring at Notepad++ while I go over how the syntax works, and a lot of it is really just look at .json files, look at the sample loot tables in the Minecraft wiki, and you'll start to understand how they work. And then basically just swap out values to make your own. So it wouldn't be terribly interesting. So I think I'm going to axe it in favor of this. But regardless, I went way over the time I thought I was going to go over, but c'est la vie. I had fun with it. Hopefully you did too. Thanks so much for watching, y'all.